We were looking at the effects of an increase in G in the goods market model, where we looked at how when we increase G, we can see the increase in output, which we said we can measure on the horizontal or the vertical axis over here. We talked about this before, is larger than the initial increase in G. And we said this is due to what we call the multiplier effect. So let's talk about now, where does this multiplier effect come from? Now there are two key equations here. One is our demand equation, that the total demand for goods or aggregate demand is C plus I plus G. So we haven't written net exports here because we're assuming it's a closed economy. The second is our consumption function, where C is a positive function of Y. So these are the two key equations behind the mechanism of the multiplier effect in our goods market model, the demand equation and the consumption function. Now let's see what happens. Now, as G increases by delta G, we know total demand directly increases by delta G because we know G is one of the components of Z, right? So G increases by delta G, demand increases by delta G. Now, when demand increases by delta G, Y also increases by delta G as firms respond to changes in demand. Because remember, our short-term assumption in this model is output is demand determined. Output is whatever demand wants it to be. Any changes in demand result in one for one changes in output. So when G increases by delta G, we know G being one of the components of Z causes demand to increase by delta G. And since in the shortened output is demand determined. Output is whatever demand wants it to be. So when Z increases by delta G, Y increases by delta G. But like we said, let's go back to one of our key equations. It's a consumption function equation, where C is a function of Y. So we know, okay, but when Y increases by delta G, C increases by C1 delta G, since like we said, this is one of our key equations. The consumption is a function of income. And this is the beginning of the indirect effects of the shock. Right, so this when G increased by delta G, that caused Z to increase by delta G and caused Y to increase by delta G. That's a direct effect of the increase in G, right, on output. This is the beginning of the indirect effects of the shock, where because of the increase in Y, C increases as C is a function of Y. Now, when C increases by C1 delta G, that will further increase Z by C1 delta G because C is also one of the components of Z. So if C increases by C1 delta G, Z increases by C1 delta G. Now when demand increases by C1 delta G, further increase in Y by C1 delta G, because remember short-term assumption is output is whatever demand wants it to be. Any changes in demand result in one for one changes in output. So demand changes by C1 delta G, output changes by C1 delta G. Right, so this is the indirect effect on output. The direct effect was this, but this is the indirect effects because of consumption being a function of income. And the process continues until we reach the new equilibrium, right? Because when Y increases, now this will further increase C, which will further increase demand, which will further increase Y, and the process will continue until the new equilibrium is restored. So output initially changes by the same amount as change in G. Like we saw, initially output does change by delta G as well. But the final impact on equilibrium income is much bigger than the initial change in G, as increase in G has both direct and indirect effects on output. This was the direct effect on output, where output changed by the same amount as the change in G, but there were indirect effects on output as well because of the fact that consumption is a function of income here, right? So which is why when you were looking at this graphically, we saw the increase in Y is more than the initial increase in G because of this multiplier effect. In short, higher G means higher demand, which means higher income because of our short-term assumption that output is demand determined. Any changes in demand result in one-for-one changes in output. Higher output income means higher consumption because consumption is a function of income. And because consumption is a component of demand, it means higher demand and income again. So keep in mind the underlying mechanism for the multiplier in the simple model is induced consumption, right? So this is where the indirect effects of the shock start, right? Now, the question arises, why doesn't the multiplier process go on forever? It eventually does stop when you reach equilibrium. The answer is that only a fraction of the increase in income is consumed at each stage, right? MPC is less than 1. If we go back, we said C increases. C does not increase by delta G here. C increases by C1 delta G, right? Where C1 is less than 1, it's MPC, right? So at every stage, consumption increases by only a fraction of the increase in income. So successive increases in income become smaller and smaller in each round of the multiplier process. Because at every stage, only a fraction of the income is consumed. So then every time the increase in income that results from that increase in consumption also becomes smaller and smaller, right? Because of leakage is saving until equilibrium is restored. So it's not going to go forever. Because it's not like, because over here C is not increasing by delta G, it's increasing by C1 delta G. Next time it will increase by C1 square delta. Because when Y increases by C1 delta G, C would increase by C1 square delta G. So every time the increase in C and hence the consequent increase in Y will become smaller and smaller until you eventually reach equilibrium. So the multiply process doesn't go forever because only fraction of income is consumed at each stage as MPC is less than 1. So this is the multiply effect, which says that when in this case, when you're increasing G, the total effect on equilibrium Y is greater than the initial increase in G because the increase in G has both direct and indirect effects on Y. And the underlying mechanism behind the multiply effect in this simple model is the fact that consumption is a function of income. So in this simple model, these are the two key equations that explain the mechanism of the multiplier effect.